Unit 8, Day 9, Determining Points of Intersection. So a point of intersection between two linear equations are where two lines meet on a graph. And we're going to look at graphical and algebraic approaches to determining this. So as you can see in the picture here, these two lines have an intersection point. So example 1, determine the points of intersection of the first line, negative x minus 2y equals negative 4, and the second line, y equals 3x minus 5. So the steps to do this are you want to graph both lines using the appropriate method. So is the slope y-intercept method better for one of them, or is the intercept method better for one of them? Then you want to determine the coordinates of the intersection point from the graph, and finally verify that that point is correct using the left side equals right side check method that I will introduce later. So let's start by first making sure that they are in the correct form and deciding which form we're going to use to graph them. So for this first one, let's put it into standard form. So we need to make the a term positive, and then it will be, and rearrange the terms, and then it will be in standard form. So let's multiply everything by negative 1. And finally, let's bring the c term to the other side. So now it is in standard form. The best way to graph this one is the intercept method. So let's find the x and y intercepts so that we can graph it. Therefore, the x-intercept occurs at 4, 0, and the y-intercept will let x equal 0, therefore the y-intercept occurs at 0, 2. So we can now graph this line by plotting those 2 points and connecting them. So let's plot these points. So the x-intercept occurs at 4, 0, and the y-intercept occurs at 0, 2. So now if we connect these 2 dots, we'll have our line for the first one. To graph our second line, which is y equals 3x minus 5, the best way to do it is the slope-intercept method. So we'll plot our y-intercept, which occurs at 0, negative 5, and we will use the slope to find the next point. So the slope is rise over run, so 3 over 1, so we will go up 3 from this point, and to the right 1, and then we will connect those points. So let's start by plotting 0 and negative 5, and now we'll put our pencil on that point, and we'll use the slope to move up to the next point. So we do a rise of 3, and a run of 1. Now we have to connect these 2 points, and we will have our graph. Notice that I extended this line so that it would cross the other line. It still goes through these 2 points, so we know that the line is correct. But now we can see that our intersection point is occurring at 2, 1. Finally, to check that this intersection point is correct, we want to verify using the left side equals right side method. So that method is such that you plug this point into both the original equations of lines, and you see if the left side equals the right side. So let me show you what that means. Let's take the first line. So the first line was y equals 3x minus 5. Now we plug in the point 2, 1 into this equation, and we solve the left side and the right side, and we see if they become equal. So the y point is 1, and the x point is 2. Now the left side we have nothing to simplify, but the right side, let's simplify it. So 3 times 2 is 6, minus 5, 1 equals 1. The left side equals the right side. So for this equation, it's correct. Let's just verify the second equation, and then we can confirm our intersection point. So the second equation is negative x minus 2y equals negative 4. So let's plug in 2 for our x and 1 for our y. And then let's simplify the left side and the right side. So the left side needs simplifying. So negative 2 minus 2, on our right side there is no simplifying. And we end up with negative 4 equals negative 4. So the left side equals the right side for both equations. Therefore, we can confirm that the intersection happens at 2, 1. So we just learned how to find the intersection point of two lines by graphing. Now let's look at the way to find the intersection point of two lines algebraically. So example 1, determine the point of intersection algebraically between y equals 2x plus 3 and y equals negative 3x minus 7. So I want you guys to notice that each of these lines are written in the same form. They're both y equals something. Y equals something. So because that's the case, we can set y equal to y. So y is equal on this side to 2x plus 3. And over here, y is equal to negative 3x minus 7. So I've essentially just put these two equations equal to each other. Now, since we only have one variable, we can solve for x. So let's combine the like terms. So let's put all the x's on the left side. And let's put all the constants on the right side. And then let's combine. So we have 5x and negative 10. Now we can solve for x. So now this x that we have found is actually the x coordinate of our intersection point. So to find the y coordinate of our intersection point, we just need to plug this x value back into one of the equations and solve for y. So let's plug this x back into y equals 2x plus 3. And it doesn't matter which one you choose. So y is equal to 2 times negative 2 plus 3, y is equal to negative 4 plus 3, y is equal to negative 1. Therefore, the intersection occurs at negative 2, negative 1. And again, we can confirm this by trying the left side, right side check method. So let's do it for the first one. So y equals 2x plus 3. We plug in negative 1 for y and negative 2 in for x. And we see if the left side equals the right side. And it does. The left side equals the right side. Perfect. Now we just need to confirm with the other line, and then we are set to conclude that the intersection does occur at that point. So the second line is negative 3x minus 7. Plug in negative 1 for y and negative 2 in for x. And again, the right side and left side are equal. Therefore, that is the intersection point of those two lines. So again, that is the way of solving for the intersection point algebraically. So the steps to solving for the intersection point algebraically are: first, make sure both lines are in this y equals mx plus b form. Then, since the y's are equal, you can set the y equal to the y. And then you want to rearrange, combine like terms, and solve for x. Once you've solved for that x, plug it back into one of the original equations and solve for y. And then once you have that intersection point, you just need to verify that the left side equals the right side, and then you can confirm your intersection point.